In this example, we'll be using the current divider rule, or current division, to find currents I1 and I2. To do this problem, current divider works when we have resistors in parallel. And right now we have these two resistors in parallel. So let's redraw that. So I have 20 ohms, and it is in parallel with the 5 ohms. The 1 amp, sorry, not the 1 amp, the I1, not 1 amp, goes through the 5 ohm resistor. And so if we set this up to look like our example, we need to know what current comes in here. So the current that comes in here is this I2. So I2 will go through the 6 ohm. The 6 ohm won't change its current. It'll produce a voltage, but I2 will enter this node, and I2 will also leave this node. So once I know I2, I can then apply current divider here. To find I2, we can see that the 36 amps is going to divide between the 8 ohm and I2. So let's draw that side. So we're going to redraw the circuit to look more like an example. So we will have our 36 amps entering our node. It'll divide amongst an 8 ohm. And then, so we have a bunch of resistors down here. If I combine all of them, they are in parallel with the 8 ohm. So we're going to have some R equivalent down here. And then we'll have, so 36 amps will come back out. And what I need to know is I2. All right. So let's start with the circuit where we know the current coming in. To solve this, we need to find this R equivalent. We can do that using the lumped resistance stuff that we looked at last time. So this total thing so we have I2. Actually, let's not draw it that way. Let's draw our entire circuit. All right. So we have 36 amps entering. We have 8 ohms up here. We have 6 ohms. We have 20 ohms, and we have 5 ohms. We start off by noticing that these two are in parallel. We can simplify that down. So 1 over some RE, some equivalent resistance. So it's 1 over 20 plus 1 over 5. The common denominator is 20. So we get 1 here. This will be a 4. So we'll get 5 over 20. To get the actual equivalent resistance, we have to flip this back over. So 20 over 5 equal to 4 ohms. So let's redraw that circuit real quick. We have our 8 ohms on top. We have our 6 ohms on the bottom. And then we have our 4 ohms that we just found. And now we just combine these two. And so this RE that I actually wanted to find up here, so if you want to, you can make this one prime, will be 6 plus 4, which is 10. All right. So let's bring this back down and solve it. So we will have 36 amps entering. We have 8 ohms, and we have 10 ohms down here. All right, and then we will have I2 going through this 10 ohms. So I know that it goes to the 6 ohms here, but the I2 is actually going to go through all of this. So it's through the 6 ohm, and then it divides and comes back out. So remember, we have I2 at the backside as well, based on KCL. So this entire lump of resistance will see I2. All right, so current divider states that I'm looking for So it is Ix, actually, sorry, let's use the lowercase I there. Doesn't really matter, but just to be consistent with what we have on the equation sheet. Ix, Rx equals I total, R total. So we care about finding I2, which is across a 10 ohm resistor. The total coming in is the 36 amps, and it is going to divide over the total resistance, so we need to find that. So 1 over R total is 1 over 8 plus 1 over 10. The common here, I believe, is a 40. So we have a 5 here and a 4 here, which will be a 9 over 40. And then we flip that and we put it up here. So we'll get a 40 over a 9. And then we solve this for I2. And we will get 16 amps. All right, so that means we can bring that back up here. That was I2, so now we know that this is 16 amps coming in, and we can apply current divider again. So this is a much simpler looking case. We don't have to do a whole lot of extra math here. So again, it's Ix, Rx equal to I total, R total. So in this case, Ix is I1, so that's what I'm trying to find. Rx, so this is through the 5 ohm resistor. The total is the current that's coming in and being divided, so this is going to be our 16 amps. And then our total is this 20 and this 5. So we already did that earlier. We found that it was 4. So I'm not going to do that again, but it's the same thing that we just did. So we do the math there, and we will get 12.8 amps when you do the algebra there. So again, you can verify these numbers by applying Ohm's law, KCL, and KVL. So the fundamental laws will help you if you want to go backwards and just check that everything matches up.